Okay, so today we're going to go through probability work relating to sample space tables when we've got multiple events happening, and then we'll do some tree diagrams separately. So when we've got multiple steps in an experiment, a table is a great way to display possible outcomes to help us decide what those outcomes could be if it's not always clear. It's important that they're listed consistently, so the order matters here, because an outcome in a different order is really a different outcome. So for example, heads then tails is different from tails then heads. So we're going to look at experiments that can be conducted with what's called with replacement or without replacement. And that just means whether we put the first outcome that we draw or get out back before we draw another one. So let's have a look at a couple of examples. So 2 coins are tossed, draw a table to list the sample space. So now a table to list the sample space is literally just a table. How many elements you put in it depends on the question. I'm just going to put this many. So toss 1, I'm going to get a head or a tail. In toss 2, I'm going to get a head or a tail. So this is where I'm going to list the possible outcomes in the order. So first I'm going to get a head, and then I'm going to get a head. Then I'm going to get a tail, and then a head. Then I'm going to get a head, and then a tail. And then I'm going to get a tail and a tail. So there are total possible outcomes. So you can read that straight off the table, and that's often a really easy way to do it. Now, the next one's the probability of obtaining a head or a tail. So probability head, tail. So it's asking for it in that order. So order matters here. So just like we talked about before, the little formula for finding probability is the number of heads or favorable outcomes, in our case, heads or tails, over the total number of outcomes. And in this case, if we go to our table, we can see that there's only one outcome down here that's a head and then a tail. So one outcome out of 4 possible outcomes. So 1/4 is the answer. The next question is find the probability of getting one head. Now, it doesn't care about the order here, it just wants one head. So that means we could get a tail and then a head, or we could also get a head and then a tail. It doesn't care about the order. So we can see that there's 2 possible outcomes of 4 for that, and of course we should simplify down to a half. So hopefully that's pretty clear. The next question is where we're going to do one without replacement. So 2 digits are selected at random without replacement from the set 1, 2, 3, 4. So we're going to draw a table to show the sample space. So this one's going to be a little bit different. So let me draw up my table. You, of course, are going to use a ruler. I don't think I put in enough. I didn't. So I'm just going to fix that up. Didn't put in enough numbers. Oh, it's not going. Table drawing's not going brilliantly well. Let's just try one more time. All right, 1. That looks better. Okay, so 1, 2, 3, 4. So this is going to be my first draw, and this is going to be my second draw down here. 1, 2, 3, 4. Now notice it says without replacement. So if I draw a 1 in my first draw, I'm not going to be able to draw a 1 again because there's no 1s left in the box. So that is not a possible outcome I could get. Now the second one, if I draw a 2 first, I will be able to get a 1. If I draw a 3 first, 1 will still be there. If I draw a 4 first, 1 will still be there. So hopefully you can see the pattern that's starting to emerge. Now, our next one, if I draw a 1 first, 2 will definitely still be there, so I'll be able to do that. However, if I draw a 2 first, 2 will no longer be there, so I won't be able to make that happen. If I draw a 3 first, 2 will still be there. If I draw a 4 first, 2 will still be there. So I'm hoping by now you can see the types of outcomes you're going to get. So always think about, if I take one out, am I going to be able to do the next one that it's telling me I want to do? So 12 possible outcomes if we add them all up across this table. 12 possible outcomes. Okay, so that is A. B, find the probability of getting a 1, then a 2. So we can go straight to our table and look at that. So getting a 1 first and then a 2, there's only one possibility of that out of all these outcomes, so that's going to be 1 in 12. Also, the probability of getting a 4, then a 3. So the same type of situation, we can only get a 4 once first and then a 3, so again, 1 out of 12. Part C of the question says, find the probability that both numbers will be at least 3. So probability, both at least 3. So that means if we have a look at a table, we don't want any 2s, we don't want any 1s. So any outcomes here that have got a 2 or a 1 in it, we can disregard. So in this case, we want the probability of getting a 3 and then a 4, or probability of 4 and then a 3. Remember, we can't get a 3 and a 3, so that's not a possible outcome. So that means we've got 2 possible outcomes out of 12, or 1/6 is our probability. Now, the next one, probability that the outcome will contain a 1 or a 4, or a 4. So because we want a 1 or a 4, that means we don't want any probabilities that don't have any 1s or don't have any 4s in it. So in this case, it's probably easier to use the complement. Take 1 and take away what we don't want. So we don't want a probability that has no 1s or 4s in it. Because if we have a quick look at the table, there's quite a lot that have got 1s or 4s. So let's have a look what that is. Okay, so let's have a look at how many have no 1s or 4s in them. So I can only really see 2, and that's 3, 2, and then 2, 3 that have neither a 1 or a 4 in it. So that means 2 out of 12 outcomes have neither of the values in it that we can have. So 10 out of 12 or 5/6 in this case. Okay, so the outcome will contain a 1 and a 4. Now that is not the same situation as what we just looked like. So it has to contain both those numbers. So in this case, there's only 2 possible outcomes that can contain that. It's going to be 4 and then a 1, or a 1 and then a 4. So 2 out of 12 or 1/6. And then the last question, for the probability, the outcome will not contain a 3. So the probability that there is no 3 in our outcome. And if we have a look at it, that means there's quite a few of them there. We can just look across our table. So 2 and 1 is one of them, 4 and 1. So we've got 1, 2, 3, 4, 5, 6. So we've got 6 out of 12 possible outcomes that don't contain a 3 or half. Okay, thank you.